Hey there, welcome back to another installment from the Basics of Lubricant series. In this video, we're going to talk about wear and corrosion, and in particular, how high-quality engine oils can help protect engines from wear damage. The way oil protects an engine is not always obvious. An oil that's going to provide great wear protection doesn't look any different from any other bottle of oil. Most modern machinery have parts that run at high temperatures and are small in size, which means that the pressure pushing these parts together is too great to keep them apart. Because of this, metal surfaces are close enough that they can actually touch and wear starts to occur. So, how do you protect them? You can coat them with something protective, like the special paint used on this gate, which protects it from everyday use and wear. Coating the surfaces with a protective film will stop the two surfaces rubbing together as the parts are moving. Now, if you make that protective layer fairly hard, then it will wear away slowly. And if you can make it self-healing, then it will build up more of itself as it gets progressively worn away. All sounds a bit challenging, eh? Well, it is, but it turns out it can be done. High-quality engine oils contain substances called anti-wear additives. Anti-wear additives are used in lubricants to prevent two surfaces rubbing together and wearing away. The oldest, cheapest, and most famous anti-wear additives, which almost all engine oils since the 1950s have in them, are called ZDDPs, commonly known as zinc. Actually, it's short for zinc dialkyl dithiophosphate, but that's a mouthful, so if you call them ZDDPs, it's easier. Now, ZDDPs are not the only anti-wear additives out there. There are actually hundreds of types. But every bottle of high-quality oil you pick up, which says it protects against wear, will contain at least one anti-wear additive. It's important to remember that not all additives are the same. Some are better than others, and the amount of additives in a bottle does make a difference. Making a good lubricant is kind of like making a smoothie. If your proportions are not right, it might look okay, but it will taste awful. It's about getting the balance of ingredients right. ZDDPs and other anti-wear additives grow a bonded layer on metal surfaces that are rubbing. This layer is hard and durable, protective, and self-repairing. In some industrial machinery where the pressures inside engines are very high, additives called extreme pressure or EP additives are added to the oils. They perform a very similar job to anti-wear additives, and they're used to decrease wear of parts that are exposed to very high pressure. The EP layers give extra protection to stop scuffing damage. For older engines and engines with over 75,000 miles on the clock, the parts start to wear more and have a tendency for the seals to leak, resulting in higher oil consumption. For these engines, it's very important to use a high-mileage oil. High-mileage oil contains additives that condition seals, helping to prevent oil leaks. It might cost a bit more, but can be well worth the money if you have an older car or the mileage is high. There are various types of wear that can occur in an engine. You'll hear terms like adhesive wear, abrasive wear, scuffing, fretting, polishing, and corrosive wear, like rusting on an iron gate. Each is subtly different, but in all cases, the protection mechanism is essentially the same. To prevent corrosive wear from occurring, we can do one of two things. Put something in the oil to create a protective layer, which will help to prevent the parts from becoming damaged. Or we can put a substance into the oil to intercept the attacking molecules or particles that can also cause damage in an engine. Without adequate protection, components in the engine will wear down, leading to inefficient operation and eventually premature failure of components of the whole engine. So it pays to make sure the level of protection from your lubricant is the best that it can be. In this video, we have talked about how high-quality oils contain a higher proportion of additives than low-quality oils. There are, however, certain challenges when it comes to the most modern lubricants. These days, thinner fuel economy lubricants need better anti-wear additives, and hotter modern engines demand more protection to prevent corrosive wear. While modern engines need better and more protection, exhaust catalysts and particulate filters can't cope with the high levels of zinc from the anti-wear additives. So we need more protection from less additive. That challenge will keep us scientists busy for a while. I hope this has been a useful video, and as always, if you have any questions, just contact your Shell account manager. I'm off to finish painting my gate. So for now, take care and be safe out there.